Hi, this is problem 11 from the 2024 AMC 10A. How many ordered pairs of integers mn satisfy the following equation? All right, since we have a square root sign involving integers, we have a few constraints right from the get-go. By definition, the square root always maps to the positive root, so we have that m greater than or equal to 0. We have to avoid a negative sign underneath the square root operation, so we also have that n has to be greater than or equal to 7 or less than or equal to minus 7. So provided we satisfy these constraints, we can square both sides of the equation to arrive at n squared minus 49 equal to m squared. Now I see an opportunity to form a difference of squares. And that's always a good target because we can now factor the left side. And on the right side, we try to write 49 as all possible factor pairs. In this case, 1 times 49, 7 times 7, 49 times 1. Now we have to consider the negative version of these factor pairs because these factors can be negative. In this case, minus 1 times minus 49, minus 7 times minus 7, and minus 49 times minus 1. All right, that's a good start. Now we have to figure out how these factor pairs map to the variable values for m and n. So let's see. Now we can extract the variable value for n by adding these two factor pairs together to cancel the m's and then divide by 2. So the n value for the first factor pair is 1 plus 49 divided by 2, 25. 7 plus 7 divided by 2 is 7. 49 plus 1 divided by 2 is 25, and so on. Now to extract the variable value for m, we can take the first factor pair and subtract the second factor pair to cancel the m, and then divide by 2. And so the m value for the first factor pair would be 1 minus 49 divided by 2, 7 minus 7 divided by 2, 49 minus 1 divided by 2, and so on. Great, so we have 6 ordered pairs in total, but now we have to figure out which of these ordered pairs satisfy our initial constraints. So for the m value, we need m greater than or equal to 0, so these two ordered pairs don't satisfy that. The m values for the others are okay. For the n value, we need n greater than or equal to 7 or less than or equal to minus 7. These are all okay for that constraint. So we have 4 ordered pairs that satisfy all the constraints and the equation for choice D.